Hey, Space Cadets, happy Tuesday. This is your Pathfinder pilot, Ryan Duffy speaking, and I'm excited to welcome you back to another episode of the show. Today we will be chatting with Joel Spark, an engineer, entrepreneur, and space science enthusiast. In 2012, Joel co-founded Spire Global, which uses a fleet of miniature satellites to gather data in remote regions of the world for ship monitoring, weather forecasting, and other RF sensing applications. RF, by the way, is short for radio frequency. You might hear that acronym a bit today. Flash forward to today, and Spire is flying one of, if not the, I believe, largest multi-purpose satellite fleets out there in space. And the company is also publicly traded on the New York Stock Exchange, having gone public by what else? A SPAC, or Special Purpose Acquisition Company. Joel is the chief satellite architect at Spire and the general manager of its space services business, which I am really excited to dig into today. The pitch for Spire Space Services is essentially that you can launch your application or product to space, and Spire will abstract away the complexity of space. So I think there's a lot more to talk about Spire Space Services, the many use cases for this technology. But I want you to hear all about all of that from Joel. So we will bring him on after a quick word from today's sponsor. Today's episode is brought to you by Kepler Communications, a company bringing the internet to space. Kepler is developing the infrastructure to support out-of-this-world communications by creating solutions that allow operators to access data in real time. The Kepler network will keep customers connected to on-orbit assets through optical inter-satellite links, which significantly increase capacity for mission-essential data downlinking to Earth. Kepler's services will expand your mission potential, all while solving current and future gaps in global space communications. To learn more about Kepler and how they are modernizing space communications, visit kepler.space. Again, that's kepler.space. Joel, welcome to Pathfinder.
Hi, thanks for having me.
Where are you dialing in from today?
I'm dialing in from Canada. It's a bit of a long story. So unfortunately, I'm usually based out of Scotland, in from Canada today.
Great. Well, I always put on our YouTubes, like the location that the guest is calling in from, and it's so fun because space is so global, and so it's all over the world. So I might cheat and just put Scotland, but
totally
that's okay.
Yeah.
Thank you. As long as I have your permission. I recorded the intro with you on the call. This is the first time that you and I have met and are actually chatting face to face. And you can't believe everything you read on the internet. So how'd I do with that short kind of bio description?
It was perfect. The only slight correction is I'm no longer the general manager of the space services.
Okay.
So I was general manager for the last 18 months and have changed to the chief satellite architect.
Okay. Does that include space services?
Yeah. So my remit now includes space services as well.
Okay.
So I'm looking
Gotcha. Okay. Yeah. I added those two. That's on me because there's the chronological timeline on LinkedIn. But our listeners have heard. Our listeners have heard the short version of your resume. What I'm curious to know is, going way back, how you were initially spacepilled, how you got into space.
Yeah, it's a good question. Like, are space nuts, are we made or born? I think is a really interesting question. I don't quite know the answer for myself. When I was a kid, I really got into astronomy. I was part of I grew up in Canada, so I was part of the Royal Astronomical Society of Canada. They had a telescope building thing. I was really, really fortunate to be able to go to the International Space School, which is a program put on by NASA out of the Johnson Space Center, where it's not just space camp. You get a chance to actually go and meet with astronauts and people doing real things. And I was there shortly after the Columbia, failure. And so seeing how NASA kind of came out of that and really seeing how the nuts and bolts of the space industry worked was a hugely formative experience. So it's always a bit of a nerd, unfortunately. I can't pinpoint exactly when it started. But that was kind of my intro to it.
Yeah. Forgive the pun. The spark was always there.
Oh, absolutely. Yeah. You can take the spark out of space, but you can't take the space out of spark for sure.
So your education, kind of academic upbringing, let's actually just jump all the way to linking up with your co-founders and the origin story for Spire. And of course, I'll give you the floor in just a moment, but I also want to call out and again, of course, your version of the story is is the right one. So tell me if any of this is wrong. But as I understand it, Spire did at some point start as a Kickstarter, a CubeSat Kickstarter campaign, right?
Absolutely. So we all met at the International Space University, which sounds like a made up place, and it's not in space; it's in Strasbourg, France. And while we were there, it was actually out of Peter. So he's our CEO and one of the co-founders. His thesis was looking at what was capable from these nanosatellites. So this is around circa 2012. So CubeSats have been around for just under 10 years, but they were kind of really starting to take off from a technology perspective. Moore's law was coming to space, and he compared the perception of the technology capabilities in the space market at that time to the kind of fundamentals, and saw that the perception was that they were growing linearly. The reality was they were growing exponentially. And that was, okay, this is an opportunity to provide some real value and have some real impact. So we thought, all right, our initial business plan was we will start, because we're also all very interested in education. So we said, let's start with ArduSat. And we ran a Kickstarter campaign around this. The idea that we would launch satellites and put the power of those satellites in the hands of anybody, and in particular students. So allow anyone to write code, upload it to space, and run experiments and gather their own data. The thinking being, if we can generate enough critical mass with this, we can eventually deploy a fleet of satellites which will provide data that will, change the planet. Our mission has always been to, improve life on Earth using data from space. And what we found pretty quickly was, so we did a Kickstarter campaign to test the waters with this idea. We hit our target in like 3 days, and we ended up being about 3 times our initial goal. So we all went to San Francisco to kind of get started. We were in the Lemnos Labs incubator, which was perfect because they were focused on startups that were doing hardware, which is quite rare in Silicon Valley. And at the time, one of their founders was a space person. He was, I think, ex-Navy. So he was tremendously supportive of that. So pretty quickly realized that it's very hard to bootstrap a space data company off an ed tech company. So we went a slightly different route where we decided to be venture backed. So we took venture funding and we spun off ArduSat into a nonprofit and just gave them data for free for a number of years. And then the rest was history.
Yeah. What were the hurdles for ArduSat? You had to book a launch. You obviously had to, build a satellite and integrate the payload, assemble everything. I think it's fascinating. You talked about kind of the perception and reality gap in terms of what folks thought it was possible to do in space versus what you could do in space given these tech tailwinds. But I would still imagine that it was very difficult to quite literally get that first satellite off the ground.
Yeah, and it's still true today, and was particularly true when we were getting started, that there was the perception, or you could say there's the data sheet, and then there's the reality of how much flight heritage and how much does something work, or does it work? And that experience actually eventually became the nugget which formed space service. Because that was a problem we saw within the space industry itself that we sought to help resolve. Getting a satellite assembled and working is hard enough, and getting into space and getting it to high nines was even more challenging. It's the usual things: regulatory, technical, everything.
Can you? We've got quite a interdisciplinary audience listening to this. I think with the high 5 nines, high nines, you're talking about reliability, right? Can you just really quickly unpack what that means? I've always thought that concept is fascinating. It's obviously important for everything from satellites to factories to what have you.
Yeah, there's a principle, kind of the idea that it takes 20% of your effort to get something 80% working, and then 80% of your effort to get it that last little bit. Generally, getting something working as a prototype is challenging. Getting it to work as a stable system that you can rely on is far more challenging, and it's a different kind of challenging. There's a bit of a mantra: an amateur practices until they get it right, and a professional does something until they can't get it wrong. And that's the difference there. So within the context of space, that means, okay, you can put a satellite up and you can test your communication system and have it working. But will it work in all countries where you might have different licensing regimes? Will it work under all weather conditions? Will it work when a hurricane hits some of your ground stations? And if it does, how does your communications network respond to that and route data differently? Will it work during service outages of AWS? Will it, all these things? Will it work if that particular country is getting DDoS? And that's just one example. And there's many, many more examples in terms of operations, manufacturing, launching, that when it comes to deploying a satellite system, there's one set of challenges to launch and get your first data from a satellite. And there's a whole second suite of challenges when it comes to being able to do that every day, very little downtime, and be able to then rely on that data for really critical applications.
Yeah. And then there's another challenge of commercializing that, right? Making a working business out of it.
And there's a further challenge about getting it licensed. Even if you can do something technically and commercially, then convincing all the relevant regulatory authorities to let you do it.
Yeah. Yeah. This isn't your domain, but we've had some launch company founders on this podcast, and it's always funny because they get on Twitter. Everyone naturally kind of gravitates, of course, to launch, because of the shiny, sexy nature of a launch. But like, there's this WEN launch. It's like people will always respond to every tweet of the launch company. It's like win launch, and it's like there's more to it than you might think.
Absolutely.
Not least of which is the licensing and regulatory piece. So I do want to baseline and set like kind of just a sense numbers wise for our audience of where Spire is today. How many satellites are you currently operating in or on orbit?
Yeah. So from a high level, so we were founded in 2012. We launched around 4 satellites between 2012 and 2015 that we built together literally in garages in San Francisco. Our clean room was just a less dirty room of the office, that kind of thing. Starting in 2015, we set up our manufacturing site in Glasgow, Scotland, for a whole variety of reasons. And we started our building of our constellation. We're a little bit in this weird space where we're launching lots of satellites. So we've launched, since 2015, we've launched 150, 100 of which are still in space, and we are operating them today. The remainder were in lower orbits, and so they've decayed and burned up. But it's not 150 of the same version, and that's actually kind of what our niche is. As it was 150 satellites of 30 unique versions over 6-7 years. So we're talking about kind of like a biannual design technology replacement cycle. Because our focus was really on where we saw nanosatellites, and we use CubeSats, but nanosatellites in particular had this ability to provide real change, where applications where you got value by being everywhere, like tracking things like aircraft and ships, or weather data where you need to provide a global view of what the weather system is in quasi real time, which means you need a lot of satellites. You also need a lot of launches. And so that pairs nicely with an iterative development strategy where, okay, if you're launching every month, every quarter, you can also be constantly iterating and improving your technology. And so that's what our task was starting in 2015 was how do we build a system that can produce satellites at a regular cadence at the time, high volumes, in kind of dozens, but also be constantly changing that design and still have it work when it gets to space. And then we took it a step further by making everything based on software-defined radio, which the analogy I would make is a normal radio is like a guitar, right? You can play it in a lot of different ways, but it's an analog system. It'll always sound like a guitar. Whereas a software-defined radio is like a laptop. You can make it play like a guitar. You can make it play like a pipe organ. You can make it play sounds that no analog instrument could ever produce. And so we focused on software-defined radio because once they're in space, you can reprogram those satellites and use them for applications that you never thought of or didn't even exist when you launched the satellite. And so by the numbers today, Spire's launched 150 satellites, around 100 in space today. We provide global ship tracking, aircraft tracking, weather forecasting data. And we also use that machine that we've built for manufacturing and launching and operating satellites, new satellites, and getting data down from them reliably for third parties to use their space service.
Right. So I'm about to say 35 words, and it's going to sound like I'm just summing up what you said, but I have like a timestamp because it's from a story I wrote about Spire, like after Q4 results. So it's from like a year and 22 days ago. It's 35 words. I just put it in a word counter. Spire has a nanosatellite factory in Glasgow, Scotland. The company adheres to the Agile development, vertically integrated school of satellite design, which stresses compact form factors, rapid iteration and refresh cycles, and software-defined reprogrammable payloads. Close? Pretty close?
Correct. 100% correct.
Okay.
Yeah, absolutely.
Yeah.
The only thing that's maybe new for us is that we also host other people's applications.
Yes. And well, I'll put these in the show notes, but I have another story. Spire's space service business shines an upcoming launch. That was from last May. And that was some of the customer payloads that you were flying on Transporter 5. But before moving on, I think it's really interesting, because you mentioned this scrappy San Francisco startup era, which is, probably familiar to a lot of folks listening to this and to a lot of tech people. But that mostly until recently has been kind of on the software side. Is the Agile development, the vertical integration, all of that, and rapid iteration as well, is that partially a function of the environment in which you grew up in? There weren't many precedents for this kind of business. I suppose Spire and Planet, which was across town from you, were like of the same vintage of space companies, as in like the first new space like satellite companies. So was kind of controlling all aspects of that and being like the really tight feedback loops with production, updating like every like generation of satellite for launches. Was that somewhat a function of kind of I'm just going to repeat myself, but the environment that you started in?
That's a very chicken and egg question. Because when we were moving from, so we were all in France at university, and when we were deciding where we were going to sit, we actually had a choice between sitting. So Peter and Jeroen, the third co-founder, we were working at NASA Ames at the time, and we had an opportunity to actually sit at NASA Ames or to sit in the Silicon Valley garage. And we made a very intentional decision to say, no, we want to sit in Silicon Valley. We want to be the slowest people in the room. We were next to a hamburger making machine, and a coffee, kind of a premium drip coffee machine, startup companies. So we were always the ones, we're saying we want to get our satellite in space in 9 months, which for NASA, they would be like, that's very fast. For, a hamburger making robot, they're like, what, 9 months, not 9 days, So we were very intentional about surrounding ourselves by people that thought in this Agile method. But then to your point, we then absorbed that, and that became a kind of key part of the DNA. It's both. Yeah.
I'm glad I asked about that. Yeah. Let's get into the nuts and bolts of the applications or services you provide. And I'm going to use the acronyms, abbreviations, whatever, because they're important. AIS and ADS-B, and then we'll take those two first, and then we can go to Earth intelligence. But these are obviously massively important use cases, which we will get into.
Yes. So AIS, Automatic Identification System, was a protocol and a standard that was designed for ships to talk to each other, to automatically identify themselves to each other, and provide basic information about who am I, where am I going, what am I carrying, what's my draft, kind of stuff. And it was then, after this standard was developed and implemented, people realized you could receive these messages that were designed for ship to ship, kind of line of sight from space, as long as you were in low Earth orbit. And it provides a really, really the best way ultimately of monitoring most vessels at sea. Because I mean, if I own a ship, yeah, you can put a GPS transmitter and a little sat radio on it if you want. But if you want to track where other people's ships are, which is actually the bulk of the use cases, it's the best way of doing it. And it's a good example of where you need to be in low Earth orbit to be close enough to receive these signals. But you also need satellites everywhere because you want to be tracking that in real time like we do. And so that and ADS-B, which automatic dependent surveillance broadcast for
I would have messed it up. So thank you. I would have messed it up.
Our aviation team would have killed me if I'd messed it up too. So ADS-B is to aircraft, but AIS is for ships. It's a standard which has been implemented, and in AIS is already enforced. ADS-B is becoming enforced that all aircraft need to have it. And because it's enforced, then it's a ubiquitous standard that gives you that ability to kind of track everything. So that's a use case of kind of quasi IoT that by having a satellite network, you can track everything because it's the thing that you're tracking is self-reporting its position and broadcasting out. You don't need a big satellite. And so it's an example of where nanosatellites came in and said, here's an application that we can do better than with conventional technology because you can deploy more of them more cost effectively, you can provide better service.
Right. And that's something, identifying ships and planes around the globe, that's something like at scale that you can only do from space, right? And was it being done from space before Spire came?
It was. In both cases, it was being done. What the nanosatellite lets you do is because you can have more platforms in space, you can track kind of more in real time. And also because you can, with our method of kind of constantly iterating, you can adapt how you monitor to kind of keep pace with changing environments. So for example, AIS has this problem where because it was designed for ships to talk to each other, it's a self-organizing system where ships take turns talking. It's like a normal conversation. You take turns talking based on who's in the room with you, and people take turns, right? But if I'm in this room and someone else is in the room over there, we might be talking at the same time. It doesn't matter for the two of us because we're still having our conversations. But if you were above us and listening to all of it, it would start getting garbled and mixed up. But that's in the AIS world, they call that collisioning, where you get too many vessels in an area. And now from space, it's very challenging to receive those. Now, because we use software-defined radio and because we're constantly replacing the satellites, we're putting more and more compute power on the satellites constantly. And so the sophistication of the algorithms that you can use to pull those out and how much traffic you can monitor in a high traffic zone, we can get better and better at because our satellites are designed for a 3 to 5 year life cycle. We generally can replace them quicker than that because the technology gets so much better that you can provide better value.
Right. And to give some tangible examples, I think the most striking one was, again, really just over a year ago. I remember you published some ADS-B data showing like Ukraine's airspace basically closing, and we'll put it on for the video version of this, and we'll link to the pictures on podcast players. But it's such the before and after image is just. It's so striking because it's like an entire nation of airspace. It's gone. And then I think there are some, I think I saw a lot of folks tracking U.S. Air Force like refuelers around. This was a couple of weeks ago for the balloons to try and get like a sense of when the takedown operation. And then another one, and I don't know if this is Spire at all. If you have any. But like Elon's, this is a more kind of lighthearted one, like Elon's Jet and the whole, like those services like FlightAware, that type of thing. Are those, I don't know if you could say, but are they using Spire or some sort of similar kind of space service?
Yeah, so I can't name specific partners, but there are kind of data aggregators that take, Spire space-based data and ground-based data. Spire is actually also one of those aggregators. So we aggregate our space-based. I think a really good example of this is with in AIS again. where Spire, we aggregate data from our nanosatellite network tracking ships. We also, late last year, acquired Exact Earth. Sorry, it's 2023. But we acquired Exact Earth. So they have hosted AIS transmitters on the Iridium constellation. We also integrate that with terrestrial, so receivers on the shore, and even ships that are taking the data of the ships that they see and routing that back through conventional SATCOM. We pull all that together, plus metadata of here's the ship, plate number effectively, but who owns that? And what are they carrying? That's data that's not from the AIS messages at all. It's metadata. So we pull all that together and we provide services that actually give people the answers they're looking for. Because usually people ask for data, but they actually have a specific problem in their head that they need an answer for. So, I don't need to know where the ship is. I need to know its ETA to port because I'm the San Francisco Port Authority and I bring in, I think there's like 2 ports in California that bring in like 75 or 80% of the goods that come into the US come in through these 2 ports. So they better have a good understanding when the ships are arriving.
I'm sure you had some sort of also striking visual for when the ports got really backed up. And that was, that was like, I guess like a year ago, but
or ever given when it ran around.
Oh yeah. There you go.
What COVID has really thrown into sharp relief is how important it is to have this information in real time to know what's happening with our supply chain. Between aircraft and ships, that's like 90-95% of global trade that you can monitor in real time through these kinds of systems. You can imagine the impact.
I want to go a little bit deeper into analytics and then talk about space services and hosting customer payloads. And we will do just that after a quick break. Time for another word from our sponsor, Kepler Communications. Space operators face many downlinking roadblocks today, and they rely on decades-old technology to access critical data. Kepler is solving the downlink bottleneck by providing real-time access to satellite data, optimized latency, and high-speed downlinking capabilities. The company's hybrid network will modernize on-orbit communications with a combination of optical technology, S-band inter-satellite links, and a high-speed backhaul link to move data more efficiently back to Earth. Kepler offers a full stack of solutions with payload technology, spectrum licenses, ground infrastructure, and a satellite constellation with full orbital coverage to satisfy the entire communications requirements of your mission. Check out kepler.space for more information. Again, that's kepler.space. Okay, so we are back. And first thing I want to dive into is I've seen Spire describe itself as an space to cloud analytics provider. And I think the analytics piece, which we were just talking about, I think that's important because there's this like age-old debate in Earth observation about whether you just provide data or you go kind of up the value chain into analytics. It's obviously like a little bit different from where you sit because you're using these different types of payloads. And like, I think that there's a lot more kind of cameras and sensors pointed at Earth that's a much more kind of crowded field as opposed to the sensors that you're flying. Is that right?
Yeah, that was very intentional. Yeah. But the debate is the same. It's to what extent, if you're a producer of data, do you want to just provide that data versus add value to that data by doing some of the analytics, right? And there's really simple examples, right? Like if you go to the bank and look on your balance, they could just give you a list of transactions and say, hey, you bought this, you bought this, you bought this. But what's actually tended to be relevant for you is what's my balance, right? And so there's very basic examples of that. Okay, don't just give me this raw stream of AIS messages. Tell me where the ship is.
Yeah.
Right.
Right.
There's more, so scales of gray. Then you can say, okay, here's where the ship is. Here's where it's going. Here's the ETA, right? And by the way, here's the ETA taking into consideration a weather forecast, which Spire also produces. And knowing how that's going to affect currents and that's going to affect decision-making behavior by the captain. Then you can say, okay, well, based on these ETAs of all these different vessels, and I kind of know what's on them, what's the workload volume going to be if I'm a port authority, for example? So it's a bit of a blurry line in terms of what constitutes data versus analytics. We generally think in terms of raw data, so just the raw just the raw data, clean,
Yeah.
so cleaning it up to get kind of the stuff out of it, smart, so things more like, okay, where is it now? And then predictive. So
Yeah.
what is then going to happen? And for Spire in particular, we're really focused on getting to that predictive. And we mainly, that's where we provide most of our value is in the predictive, because predictive drives decisions, which drives value.
Sure. How does Earth intelligence, which is another one of your sort of product lines, I suppose, how does that fit into all of this? You mentioned weather too. So
yeah. So what Earth intelligence is, that's using our software-defined radio in a slightly different way. So with aircraft tracking and ship tracking, what we're doing, we're basically just receiving a digitally coded message and reading that message, and then aggregating the self-reported data. In shipping, actually, we do something a little bit smarter. We actually compare where the ship says it is we can do course geolocation and triangulation of where that ship is. And we compare that and say, okay, you say you're here, but you're actually over here. If that deviates by enough, you can start, that's intentional and you can actually take action on it. By and large, those are more just receiving and decoding and managing data. Earth intelligence, we look at how signals and radio frequency and electromagnetic waves are impacted as they interact with our planet. And from that, figure out what's going on with our planet. So a classic example, we look at how GPS and other GNSS systems, but how GPS signals are bent as they skim through our atmosphere, and how much they are bent is a function of the pressure and temperature and humidity of the air that they're passing through. And so one of our Earth intelligence products is that. It's called RO, or radio occultation. You get very actually precise and very error-free messages, data about what the atmosphere is, which is a really critical input for weather forecasting. Because obviously so much weather is driven by the atmosphere. But importantly, because you're only measuring the bending and the speed of light signal, there's no calibration. So there's very little error that then gets brought into your weather forecasting model. Weather forecasting is very sensitive to errors. The more error you have, the worse your forecast gets over time. And this is why we're I think the number one RO provider into, we provide it to NASA. NOAA uses it for the everyday weather forecast in the US. ECMWF uses it in Europe. It's a really, really impactful type of data. So that's just one example, but Earth intelligence is looking at how signals refract or bounce or do all these funky things with our planet and deriving insights about Earth.
Gotcha. Let's move on to space services, or I called it. I'm looking back at this article I wrote. I called it SPAS, Space as a Service, and that's I mean we've danced around it a bit, but the pitch, if I'm not mistaken, from like a strategic lens, is using the upfront capital investments, manufacturing prowess. You have centuries at this point. I would guess 4 centuries of flight heritage. Flying in space. Yeah. 5. Congratulations.
Yeah, over 5 centuries.
There you go. Close to kind of close, halfway to a millennium, which is kind of
that's accelerating though, obviously, right? As we launch the satellites.
Yeah. It's tough to wrap my mind around, but in return, it's like a subscription service. So let's talk a little bit more about space as a service and what the thought process was behind launching that and how it's going.
Totally. So it's I see it as an expansion of our original mission, which is using data from space to improve life on Earth. And one of those barriers we talked about, the biggest barrier is not, in my opinion, is not getting to space. And this is maybe a hot take. It's actually pretty easy to throw something up and put it in space. I mean, we did it in 9 months, right? After kind of together, right? The hard part is, what do you do once you're there? How do you deliver that data reliably to the point that the NASAs and NOAAs of the world will trust your data for their forecasting model, right? So we had to go through a lot of that already. And so the thought behind space services, that's a tremendously powerful platform that I would have given my arm for circa 2013, 14, 15, when I was trying to get my Earth intelligence and aviation and maritime businesses off the ground. I know what I want to do. I have my device working. I just want it in space. I just want to get the data from it. I just want to control it. And that's it. I don't care about licensing ground stations. I don't want to care about that. I don't, So that was the thought behind space services. How do we lower those non-intuitive, technical, regulatory, financial barriers to scale for new companies? And in so doing, enable and empower the next generation of space entrepreneurs. The analogy I kind of make is look at what cloud computing did for the web. Pre-cloud computing, if you wanted to launch,
you read my mind. I was going to say AWS. I was going to get. We were going to get Amazon Web Services for those who don't.
Exactly. Yeah. I mean, as you were pre-cloud computing, if I wanted to launch a website, all right, first step is clearing some space in my closet and buying a server and putting it in there and learning how to manage that and how to thermally manage that and all these boring things that have nothing to do with the website itself that you're trying to operate, right? And then you're successful, and suddenly you go from 100 customers to 100 million customers, and you struggle to scale. And so what cloud computing did is it brought down that initial barrier to entry, and in particular brought down the barrier to scaling. And that's what our mission is to do with space services, is to lower those barriers to entry to getting to that first light, that hello world of your application in space. But then in particular, going from hello world to you changing the world with your data, to make that a seamless and quick journey. And do that by providing a proven satellite platform, a global ground station network. The licensing for the satellite is already provided for. We help you get your application. It can be pure software or it can be a widget working in our satellite platform. And then once it's in space, you control it through a web API. And again, using all the same stuff that we use for our own fleet.
I'm glad you mentioned the word platform, because that's where I was going next. Another technology metaphor that comes to mind for me is this concept of a platform. And so that could be, 4G, 3G and 4G wireless networks, or like the iPhone App Store. And so it's a similar idea. Obviously, it's kind of a stretch because you're not going to have it. It's an order of magnitude, multiple orders of magnitude less widgets, or apps built on top of it. But it's the same idea, right? Like you have mastered, you have launch relationships, you know how to get licenses. You built out ground stations around the world. You've got this tight production process in Scotland. And so for someone who has an idea or like some sort of new sensor or something that could be done from space, this just allows them to skip all of those steps and like $100 million, $80 million.
Skip all those steps and skip all those mistakes. Because we do a lot of work with the UK Space Agency and ESA, and recently they gave us a report of kind of the biggest lessons learned of that all their new companies and all their scientists go through on new missions and old missions and everything. And you go through the list and it's like yep, seen that, and it as a space nerd, it is soul crushing to see people repeating the same mistake and solving those things which are solved problems, rather than going out and changing the world. And so absolutely, it's a platform. And the reason we chose to launch it was because we saw that Spire was quite well positioned to provide that. I mean, to your point, we already have the relationships. And even, from our data business, we're kind of perfectly tooled for this. We already needed to be constantly changing the design. So if somebody comes in with new requirements or slightly different requirements, we're used to that because we're always doing that to ourselves anyway. We're used to launching with lots of different providers and adapting when those launches fail, and remanifesting satellites. That's the beauty of the CubeSat, is you can very readily design a satellite which is enveloping all the specs in the launch market. And so when a particular vehicle has a failure, you just remanifest. And we had one example where if we had been a small company and it only booked our one slot, that failure of this particular rocket would have delayed this person by 2 years. But it delayed them by 2 months because we just moved them onto a different vehicle and they were off with the race.
And y'all, this was a while ago. Again, this was last year, but I'll put it in the show notes as well. I remember you guys got, basically signed like a launch services contract and like got on launcher like Virgin orbit in like record time, right?
Absolutely.
Record time. That's Spire's language, but like, right. It was like a super quick turnaround.
Yeah, it was 24 hours. And it was because one
that is very fast.
We had a particular set of satellites. They were manifested for one launch. That launch was delayed. We had a great and continue to have a great relationship with Virgin Orbit. And they said, "Hey, we've had somebody else back out, so we've got some space." And so we took those satellites out of the pod, put them on the new vehicle, and they were launched on the most recent successful Virgin launch.
So, what are these customers doing? I'm sure that a lot of these business dealings are wrapped up in NDAs and everything. So I'm not going to ask you to name names, but what are the customers that you're hosting payloads for? What are some example use cases of what they're doing in space?
Yeah, absolutely. And in some cases I can't name names, but in some I can. So a great one is Aurora Tech. They're a German startup company. Their mission is to provide a wildfire early warning system, where anywhere in the world, if a wildfire ignites 30 minutes later, they have a geo coordinate saying somebody needs to go and put this out before it gets to the point like today where you're trying to contain it. And so very, very smart group of people. They've put together, it's a very small multi-band infrared emitter and has some optical in there as well. And they use AI to, in space, convert the raw imagery into the actual detection. So they can get that they can go from that raw data and dirty data to the actionable insight very, very quickly. So we work for them, and it's the classic case of they don't need to think about ground stations and licensing and whatever. We integrate their camera in satellites, in some cases alongside other Spire payloads. In some cases, it's their own thing. And they get their early warning system, and they are doing great. They're using data from from their own payloads. They're using data that's available on the market, and they're already providing this wildfire analytics service. So stuff like that. That's a kind of an Earth observation style use case. There's a lot around telecom, in particular around kind of low power. So like Myriota and others, where I have a small device in the field and I want to move data back and forth. Great for agriculture, forestry monitoring, even really interestingly in offshore power, and being able to move like maintenance data and improve the efficiency of maintenance operations of offshore wind. So a lot around that. We also do a lot around signals intelligence. So looking for GPS jamming, looking for other interesting things that you can imagine. We don't
that's where Spire Federal and your government. Yeah.
Yeah.
You
so
can imagine why
Spire Federal does all of it. Yeah. Spire Federal does space services, but they also do aviation and Earth intelligence and everything. It's just a very interesting specialty to sell to the US government. And so that's what they do. But yeah, so there's a whole range. Some really fascinating ones too. There's space to space cameras, tracking space debris or doing micrometeoroid detection.
Like space domain awareness.
Yeah, that's a really big use case. So it's actually a real privilege to work with some really, really clever and motivated people that are doing incredible things. And that's why we have the platform, right? Is to give the tools and the power to those people so they can go and change the world and not solve the same problem over and over.
Right. So presuming, your launches and deployments keep going up and to the right, and you have a customer who wants to continue to deepen the relationship and deploy more and more in space, in theory, they could launch an entire constellation. Maybe there already are constellations where, instinctively, even though I've been like knees deep in space for a year and a half, I still think of like a constellation as its own like satellite. And I know that's a misconception because there are constellations that are more so just hosted payloads, right?
Right. Yeah. And it's not even theoretically. There's people doing this today who have, through us, they've deployed one, it's worked great. And they said, great, give me more. And we're off to the races with them. We were quite intentional also designing the service, legally, contractually, financially around that idea that we're just a platform on which you build. And, we're going to assume success and when we get ready. So for example, everything is subscription based. So rather than, having to fork out a huge chunk of change initially, we actually spread the payments of the customer across the service. We also were fairly unique in that we provide an SLA. So we say like, it's not just, it was working when I gave it to you. It's get this thing in space.
What's an SLA?
Sorry, a service level agreement. So if the satellite is in space, if that platform that you've built on isn't working, you're not paying, which is an important thing, especially if you're a new company and you're looking at how do I forecast my financials, right? Which is not actually that common in the space industry. We provide SLAs. We have a kind of a high level MSA that people can very quickly turn around service orders underneath. So you only need to kind of go through the legalese once. And then it's very easy to say, my first 10 are working, I want another 50. You don't need to go through a lot there. So yeah, absolutely. We're quite intentional about we're a platform on which people can build their amazing application.
Yeah. Yeah. Well, that leads us pretty perfectly into what I call relatively new segment, which is the Max Q, which is just kind of a grab bag of my more difficult questions. And the first one would be, for a theoretical space services customer, what happens if they go belly up, and there has been a pretty substantial investment in or allocation, I suppose, to their hardware on orbit. How does that impact you and your bottom line? And maybe I'm not going to try to answer the question myself.
No, totally fine. And that's a little bit of our secret sauce. We're kind of at the scale where we can kind of, be aware of that. We also have, obviously, like any company, we have risk management that we need to take.
Yeah.
So without giving away too much of the secret sauce, you have to assume that's going to happen. In the same way that you have to assume the rockets blow up, right?
Right. And you mentioned right before this that you have you built this sort of unique infrastructure covering sort of payment plan, like legal, I'm sure all that's baked in. Second Max Q question is, it's been a rough go, obviously, for space specs. And I'm sure you get this question a decent amount at the, space conference circuit around the world. And I'm sure you're tired of answering it, but how do you, there's been these drawdowns and whatnot. Do you tune, I'm assuming you're not really paying attention whatsoever to the daily trading patterns of Spire, which is your stock ticker.
SPIR. Yeah.
SPIR. Yeah. How do you and your team, is it kind of just heads down, tune it out?
It would be, it would be facetious to say that it's not discouraging, but you have to look at it within the context of the overall market, and what's happening to, the general tech sector and the general market. It doesn't really impact our daily lives, right? The stock price is going to be what it is. We know that in the long term, the stock market is a weighing machine. In the short term, it's a voting machine. There's a lot that goes into it other than the fundamentals of a company. And so that's probably the most I can say. And only because I'm an engineer. Understood. I'm an engineer at heart, and it's my first time in a public company, so I don't know what's going to get me in trouble or not. But as a founder and as an employee, it's not relevant for my daily life. Yeah.
And you are on solid footing, as you said. I think the last quarter you reported, I know that there's a bunch coming up soon, but it was record revenue and everything. And there are some other, and I am not by any means lumping all these companies into a category. There are some companies that might run into runway issues relatively soon, but again, they're not a monolith. And I know that you're pretty well positioned for the future.
Yeah, and one of the benefits of being a public company, our finances are out there. People can totally take a look. I would really encourage people to look at the fundamentals.
Yeah, right. Which is great. It's great. I get to dig into all of these details that obviously there wouldn't be. Your financials are more transparent than SpaceX, which is interesting.
As a public company.
Last Max Q question. Then we can go to the lightning round. And I appreciate your patience here with dealing with the technical difficulties and whatnot in the smoothie blender. what is the total, we talked about the cloud analogy, the platform analogy. I think that the cloud analogy applies very well, especially because the amount of complexity between setting up your own server racks versus like spinning up an AWS account, as opposed to launching your own satellite. That's a way different scale of complexity. But the one that I mentioned, which is like this idea of a platform. Of course, the App Store, it's not a good comparison. It's apples and oranges because it's a mobile device. The scale of billions and billions and billions of handsets. What is the total, in your mind, like addressable market or total universe of use cases for someone who's like trying to fly their payload on a nanosat? Like, I imagine there has to be an upper bounds.
Yeah, it's a really good question. It's one that we constantly grapple with. Early indications are pretty strong if you look at the financial. Like if you think about, the way I see it, the line between the cloud and space is getting very blurry. A lot of, we have ourselves and we have our customers deploy applications purely virtually through the satellite. So the App Store is not actually a totally irrelevant comparison. We developed and deployed a sea ice monitoring product to satellites that were designed for atmosphere because somebody much smarter than I figured out how to use the data in a slightly different way. We've had companies deploy IoT services, all these things purely virtually to the constellation without any hardware. So it's not an outrageous comparison. In terms of the total market available to it, it's a challenging to bound because there is so much that can be done, right? I mean, look at what we've been able to do with weather forecasting. What's the market for IoT? What's the market for defense signals intelligence? Ultimately the kinds of problems that we are seeking to solve ourselves and we're seeing our customers solve are things like, how do you fight climate change? How do you increase global food security? How do you, these kinds of big problems. So I won't want to speculate on what it is, but it's
yeah. I mean, trying to map out the future is a fool's errand. No one, and especially for space, no one has a crystal ball. Yeah. Before the lightning round, I would be remiss to not mention that Spire provides data to a Formula One team. I think that's super cool. I had that on my checklist of wanting to mention. I do know that you guys probably can't talk about who, but is there anything else that we haven't covered yet? Because we just hit on mine. Is there anything else that we haven't covered that you want to mention that you think it's important that our listeners should know?
No, I think you've done a good job. You've kind of covered all of us. It's generally, using data from space to improve life on Earth. The combination of we ourselves have this whole network of satellites and all the infrastructure behind it to operate them. And Spire, we have a set of our own applications, and we also have these third-party hosted. I use the word applications because they can be hardware, can be entirely bespoke satellites, and in a lot of cases, just pure software. But for me, it's the platform that is the most exciting part of it. The platform that we ourselves use, so our space services customers know that we put our money where our mouth is. I used to say we eat our own dog food, and somebody says, "No, you drink your own champagne." Yeah. So I'm trying to learn how to
yeah. One's a little bit more elegant. As a wordsmith and occasional copywriter, I think I would go, if I were you, I would go with the champagne. But
hard habit to break. That is
Well, dog fooding is like definitely a term, again, from the technology world and world of startups that applies perfectly well to what you've done and your journey. So if you could live in one sci-fi movie or TV show or book, literary universe, which one would it be?
I'm going to out myself as a total nerd. It would be Star Trek, and probably like the next generation Star Trek. If only because it's so optimistic, and I think it showcases what the best of what can be done, of applying the best minds of technology. So I would say Star Trek, and mainly next generation.
Okay. Second one, and you did already give one, but so we can return to it, but what's your hottest take, most contrarian view about the future of the space industry?
I think all the recent launch failures that we're seeing were somewhat inevitable and a good thing. Zooming out in the macro, because at least people are attempting, right? It's somewhat inevitable that it takes, you got to break some omelets to make some eggs.
Space is hard.
Are going to fail, right? At least now there's been this uptick in recent failures, but that's because people are actually making orbital attempts and in a lot of cases succeeding.
And getting to the pad. That's true.
So if we weren't seeing these, it's because people were still stuck in static fires. So I actually take it as it sucks in the short term, especially for the people who worked so hard on those vehicles and the things that were on those vehicles. But in the macro, I think it's actually a positive sign. Last
question. If you could have dinner with, this is the first time I've asked this one. If you could have dinner with any historical figure, who would it be?
I would say Carl
Sorry,
Sagan.
I had to throw a curveball. Carl Sagan.
Yeah,
okay. That's a great choice and very, very on brand for this podcast. Well, thanks, Joel. Thanks for the time. This has been a super fascinating conversation, and looking forward to following the rest of your year.
Thank you.
All right, folks. That's all she wrote for Pathfinder 0036. If you are watching this, you're getting a special treat. A little embarrassing, but in any event, I'm going to read us out. Pathfinder is powered by Payload and produced by Peter Jean. If you like what you heard, please leave us a review and rating wherever you're listening to this. It really helps move the needle, or better yet, share this with a space-inclined family member, friend, or coworker. Next week, I'm not sure who we have next week, but it's guaranteed to be a good one. So until then, this is Ryan Duffy signing off, and I will see you back here very soon.